When we think about testing, we should think about the public interface. We should think about the contract between the caller and the called. So what's the contract here, like between these things? So when the animal calls some method on the leg, where the leg is in some state, and the animal provides some particular set of arguments, what's the expected outcome? What's the expected value back? Like that's the whole thing we need to think about with testing, or like that's the key point, right? I would go from the bottom up in the whole system, right? Rather than saying, let me try to test from the outside, I would go unit by unit, small piece by small piece, from the downwards, from the bottom upwards. And I would think deeply about each particular piece, and I would say, okay, what's the contract of this thing? And I would try to reflect every one of these sort of qualitatively different outcomes in the tests to make sure that I have several cases for each of these qualitatively different things. This kind of looks like a mess, right? But it was an interesting discussion. I received this great question on my ScaleAbout page regarding how to approach testing, or how to identify an adequate level of testing when trying to refactor a legacy application. Again, thank you very much to you who asked that question. And I thought the answer might actually be useful for more people, so that's why I'm posting it here on the channel. But anyways, what I want to say also is that if you have questions, or if you feel inspired by this particular video to ask some kind of question, like, or if you have something that you want to discuss with me, do check out the link to my ScaleAbout page in the description. There's a discount code that gives you 25% off, and so do use that if you ask a question. And of course, as always, like I'll try and answer as many questions as I can, regardless of where you post them. But if you want to guarantee that I will try my best to actually answer your question, ScaleAbout is the best way currently of reaching me, because then you'll definitely get an answer. I mean, it might very well be that I can't answer your question, right? But I'll try my absolute best in order to answer your question. But anyways, too much talking. Let's get into the answers. So here's the answer that I sent to the person asking that question. Hey, yeah. So first of all, thank you very much for your question. I think it's a great question, and I guess we should sort of emphasize, or I want to emphasize this sort of, I think this is really one of these questions that don't have a clear-cut answer, or rather that don't have an easy answer, right? As in, like, but probably it seems like you're appreciating that as well. Like, I'm not saying all solutions are equal, as in, like, it doesn't matter which way you approach this. For sure, it matters what way you're approaching this. But I think even the good solutions to this kind of problem are devious or are painful. Like this is a tricky problem, and it will require a lot of pain to work through. So, I mean, legacy systems, right? Like to get rid of them, there is some level of pain involved. I would assume, like, inevitably. Anyways, but let's get to the actual question. Let me try to reinterpret what you're saying to make sure that I'm understanding you correctly. But I'm interpreting as that you're saying that you're facing this system and you want to refactor this system. You're making it more object-oriented. You're more consciously thinking about design. You want to continuously refactor, but it's a legacy system, so it might not necessarily be designed in exactly the way you want it now, which makes testing more difficult. And also, it's really important that you have enough tests to make sure that you're not breaking the code base as you're refactoring it. And so I'm interpreting sort of the heart of your question as you were saying, right? Like, what's the how to ensure that you have just enough tests, right? Because you don't want to overdo it, of course, because that would be massively expensive. And I mean, for sure, tricky problem. You were also mentioning integration tests and unit tests. So I think I'll jump on that bandwagon, and let's talk a bit about that. So the way I'm thinking about it generally, right, is that, I mean, you might know from watching some of my other videos that I'm a fan of JB Rheinsberger's talk, Integration Tests Are a Scam, where he essentially argues that, let's jump into this, right? He's arguing that, like, when you have an object-oriented application, it's kind of like you're having this graph, right? Like, now I'm drawing it as a tree, but like when your program is in memory at any given point in time, you have this object graph, right? And the point is that if you are testing, let's say this is the entry point of the application, right? If you think about it as a tree, this is like the main of the application. And then at the bottom, you have these units that don't have dependencies. But if you're testing from up here, like true integration testing, like maybe end-to-end testing, let's say, like you're testing the interface, then you don't just have to worry about the state that you have up here, but you have to worry about the number of different states that you have in all of its dependencies. So, I mean, if this is A and this is B, let me put it next here. If this is B and this is C, and if you're only testing this portion, let's say this is your own application, like we don't have this part, right? Then the number of states that you have is like the Cartesian product of the number of states in A, the number of states in B, and the number of states in C, right? So it's the number of states in A times the number of states in B times the number of states in C, which like quickly explodes. So, and that's really the true reason why integration testing is extraordinarily expensive. And also, if I'm not misinterpreting J.B. Rheinsberg, I think his point is that it's prohibitively difficult. Like the state space is so huge that we are going to miss cases, advertently or inadvertently. And that means that it's simply not a good strategy, because when we are missing test cases, those parts are untested. And that's the dangerous parts. So the reason I bring that up is that, like, if we say that it's like, if this is the legacy system, right? If we test it from the outside, and if it's like a reasonably large system, then the number of states that we have to test, if we have true like integration testing from the outside, is like huge, right? Like it's like probably in the millions of different things that we have to test, and it's going to be like tons of repetition. And again, like I would say, far from just enough. But also, again, this point of it might be that there's so many different states that it's actually dangerous to try to test it that way, because we're definitely going to miss some cases. So I would not, I mean, generally, I try not to approach testing from this perspective. What's the opposite, like, or the other extreme? The other extreme is to start from the other end, to start from the units that don't have dependencies, right? Like if you think about how we're drawing this, there are no arrows going outwards from these. I mean, sorry, these are sort of directed. I'm trying to think in terms of the order of the dependency. So there are no arrows going out from these. So these we could test without worrying about dependencies. Now, if you're designing a system from scratch, like, and you're working with low coupling, right? Like if you are consciously constructing a system that has very, very low coupling, then true unit testing is fairly, like it's relatively straightforward and it's fairly simple. But if you're working with a system which is deeply coupled, then that might be super tricky. Like if you have this thing which hard codes a dependency to another thing, which hard codes a dependency to another thing, right? Then how are you going to test this thing in isolation if it has a dependency on this and that has a dependency on this? Like, there is quotation marks, no way. Right? Like you're testing this thing, but by proxy, you have to test this thing and this thing. Like, while testing this thing. So it's like, I mean, if an animal if this is an animal object, and the animal object instantiates an instance of a leg, right? We're not dependency injecting a leg into an animal, but rather we are hard coding. We are constructing the leg within the animal. Now that means we can't, without some serious ninja movements, right? Like we can't work with an animal without also inadvertently instantiating a leg. So that means we're back into this sort of state space thing, where if this is A and this is B and this is C, and we actually only want to test A, then we have to test A times B times C. This many number of states, because we have to think about the variations that we could have in B. We have to think about the variations that we could have in C. So I'm saying that because, like, if you have a system which is truly coupled, or like has a high level of coupling, has a high level of hard-coded dependencies, then we end up in scenarios where we have to test this. But it's not necessarily a problem I mean, it's just varying degrees of pain, right? But what I'm trying to say is that you can, of course, you could test this. It's just a question of the state space becoming bigger, and this becomes, in some sense, then integration testing. But think about it this way. If I back up, right? Like when we think about testing, we should think about the public interface. We should think about the contract between, let's say, the callee and the called. Wait, maybe I'm saying that incorrect. Like let me just say, wait, the caller and the callee, right? The caller calls the callee, I guess is the, yeah. So I mean, you get what I'm saying. Like the caller and the called. So what's the contract here, right? Like when the animal calls a leg, for example. I'm sorry for the strange example, but you have an instance of an animal class and you have an instance of a leg class. The animal calls the leg. What's the contract here, like between these things? So when the animal calls some method on the leg, where the leg is in some state and the animal provides some particular set of arguments, what's the expected outcome? What's the expected value back? Like that's the whole thing we need to think about with testing. Or like that's the key point, right? We need to exhaustively specify the contract of, let's say, I mean, I have the leg class, right? Like this is the contract of the leg class. When given, let's do something more simple. Let's think about, I mean, it's silly, right? But like, let's say we have two string. No, sorry, not two string. Let's say two upper. So two upper is a function that takes a string and produces a new string. But then we have to think about it. Okay, so if it can get any string, then the whole domain of valid strings are valid inputs for two upper. Not necessarily valid, but possible inputs to upper. And then we need to think about it. Okay, for that whole state space, what will happen under all circumstances, right? So let's say, hypothetically, any string which is longer than 0 will be uppercased. Okay, and then we have an intuitive understanding of what uppercasing means. Like every letter in that string will be uppercased. And if it's an empty string, you'll get back an empty string, right? This is important because another implementation would be if you pass an empty string, you'd get an exception. Like that's another valid implementation. Maybe it doesn't really satisfy this signature, but I mean, I think you're seeing what I'm saying. Like, if that's the contract, then it's really important that that's reflected in the tests, right? So let's say there are sort of qualitatively different things that it does. So let's say that we're saying, okay, you can get back an uppercased string. You can get back you can expect an exception. You can, I mean, I guess that's it, right? Or maybe we should also say numbers are left alone, right? Or maybe non-alphanumeric, non-alphabetic characters, I should say. Non-alphabetic characters are left alone. So if you pass 1, 2, 3, you should get back 1, 2, 3, right? It shouldn't strip those away. So that's an important part of the contract. That's important that we understand that. So okay, maybe I'm drifting away now. What I'm trying to say is that that's the way I would approach this kind of thing. I would go from the bottom up in the whole system, right? Rather than saying, let me try to test from the outside, I would go unit by unit, small piece by small piece, from the bottom upwards, I'm trying to say. And I would think deeply about each particular piece, and I would say, okay, what's the contract of this thing? And I would try to reflect every one of these sort of qualitatively different outcomes, this was the same actually, in the tests, to make sure that I have several cases for each of these qualitatively different things. Something along those lines. That's probably the way I would think about it. And of course, the really tricky thing when we're dealing with somebody else's system, and like potentially when we're dealing with a legacy system, is that we might get the contract wrong. And that's like, I mean, this is a give and take, right? Like this is the really dangerous portion of unit testing. Like if I create a test for this thing and I get the contract wrong, because I only have a unit test, I have an isolated unit test for this piece, which is completely isolated from everything else, then I might actually break the whole program when I refactor this particular thing such that it still satisfies the specification, right? Not because I didn't implement something correctly according to the new test, but rather because my test was wrong, right? Because I misunderstood the specification. But I mean, the way I would think about this is that what's the alternative for that? Like, what's the alternative from sitting down and trying to understand the contract of this particular thing? Well, the alternative is to move upwards and say, okay, well, if I can't understand the contract of this thing, let me try to test on this level and downwards instead. But then I have the same problem. Like, that thing I might also misunderstand the contract of this thing upwards, right? So then I move one step more, and then I move one step more, and so forth. And then eventually we're at the top. And then we're back into this situation where it's like, where we have a billion tests that we have to write for this whole application, for every possible state that this application could be in, which is absurd. But, and what I would say is that, well, if we have all of those different cases, I wouldn't even say that it's reasonable to assume that we would identify this particular case that I was talking about misunderstanding here when we tried to test something in the bottom, right? We were saying, well, what if there's an edge case in to upper which is undocumented and, let's say, is surprising, right? Like, we didn't see it in the implementation when we read the implementation. But if we wouldn't discover that while doing the unit, or while reading through the unit, why would we discover that through integration testing? I mean, we might, right? But in my mind, this just sounds like flipping a coin, right? It's like, well, we could, who knows, right? But I don't know. I mean, maybe I'm too much in one extreme here. So I guess some people would argue that a healthy balance would make sense, or I mean, I don't think integration tests kind of make sense, but maybe what I would do if I was in a similar situation is I would have a few tests that sort of penetrate through the application. You can't penetrate through every possible state because that state space is huge, but like just a few of them to make sure that some of the wiring seems to be still okay, right? But otherwise, what I would do again is I would go step by step. I would take a small unit, write tons of isolated true unit tests for that thing, refactor that thing, and then move upwards through the chain. Another problem, sorry, now I'll try and wrap this up. This is a very interesting discussion. Again, like a super interesting question. But another thing, and I mean, I guess this is if you go into true unit testing, you will of course, while testing this thing, for example, you will of course not test it with true members downwards, right? Like, let's say that this is not a dependency, but this is dependency injected. So if we go back here, right? Like, let's say this is animal, and animal is injected with a leg here. So this is not a hard dependency, but it's like an animal uses a leg, and that leg is dependency injected into A. So B is dependency injected into A. If we only have, so there's an interface in between those, right? Like B specifies an interface, polymorphism, so B, the constructor of A, takes something which satisfies the type of B. Now, in your testing, you wouldn't, of course, test it with a real B. You would construct a mock, which is some silly B, something that behaves like B, but is absolutely trivial in order to simplify A. And what you're actually testing then is sort of the interaction between A and B. You're testing that A can appropriately interact with B. Now, the issue with this is, of course, that you're sort of locking in a particular implementation rather than testing behavior, right? It's kind of like we're testing implementation. Again, the alternative is to move more towards integration testing. So here I would probably say, well, am I in a scenario now that where I want to, for some reason, get rid of B, for example, where I actually want to change the interface, where I actually want to change the interaction, then I would start to move towards integration tests. But that's also because it's, maybe I'm getting this wrong, but I don't think I'm getting this wrong. It's like, it's not actually a true integration because I'm, how can I put this? So I'm trying to get rid, let's say there's also C here, let's say. So let's say, yes, so let's say A is dependency injected with a B, which has been dependency injected with a C. and then I'm testing that A interacts appropriately with B, let's say. But somehow I'm realizing that this is a way too complex implementation. A should be able to do whatever it needs to do on its own without having these sort of other, needing these other instances. So maybe then I'm cutting off and I'm saying, okay, let me try to actually test the behavior of A without passing B's and C's. But then I'm in like I'm truly refactoring this thing where it's like I'm actually changing the contract. A is suddenly now a completely new thing. And here, of course, we have to be extremely careful. I think I'll wrap up here because now I'm getting a bit confused even myself. But I mean, my 5 cents in summary is sort of to move slowly from the bottom up. So take small pieces of things that you understand and test those, and then move upwards towards the things that are using them. I would not approach it from the integration testing point of view, but that's mainly because of this state explosion problem. Like, it's unreasonable to expect us to be able to test all of the different states, which in some sense we need to test if we're actually doing testing. Like, if we're actually worried about the application being correct, then we need to enumerate a significant portion of the states, and that's going to be very tricky from an integration testing point of view. So we move upwards and test a unit at a time and move upwards. And then when we identify refactoring opportunities, we can refactor those. And probably, again, as we're moving upwards, we can potentially get rid of pieces. So if you have a sort of a tree or a number of different dependencies, and as you're moving upwards, you're saying, oh, but wait, this thing is actually trivial. You can cut off the things below it and refactor that particular thing while testing that particular thing, right? But not by having these humongous tests that test the whole application from the top. Anyways, those are my 5 cents. I hope that's useful. This is a super good question, yeah, I mean, if you think that I answered something else, please let me know, because then I truly apologize. But anyways, great question, and I'll see you back on the channel. Thanks.